Welcome to the deep dive. Today, we're putting on our hard hats and going into some pretty intense environments. We're talking about places where the air you breathe is literally a matter of life and death.
Exactly. Think refineries, shipyards, massive chemical tanks. These are what we call confined spaces.
And in these places, ventilation isn't about comfort. It's about preventing a catastrophe. It's about getting toxic, explosive gases out and fast.
That is the whole game. The first job isn't the maintenance itself, it's making the air safe to even begin. You're fighting things like toxic fumes, heat stress, and the big one, LELs.
Low explosive limits.
Right. If you hit that limit, you're not just dealing with bad air, you're basically inside a bomb that's waiting to go off.
So our mission today is to do a deep dive on one specific piece of gear that's kind of the heavyweight champ in this field. It's the RamFan EG8200-230.
A 16-inch, 40-centimeter EF150 blower exhauster.
And we really want to unpack why this unit specifically is at the top of the list for procurement managers and safety directors everywhere.
Well, this is really a look at a specialized solution for a massive problem. The EG8200 is, it's essentially an industrial-scale lung. It's designed to move colossal volumes of air.
So we're going to break down its technical specs, see how it performs in the real world, like in a petrochemical turnaround, and even look at the B2B supply chain that gets these things on site.
Yeah. The whole conversation really comes down to this. How does this machine move contaminated air so fast that it guarantees OSHA-level compliance and keeps people safe?
Okay, so let's get right into it, the technical muscle. When we say raw power, what really sets the RamFan EG8200 apart from, other blowers you might see?
So the first thing to understand, the basic facts, are that it's a 16-inch blower powered by a 1.5 horsepower motor.
Which 1.5 HP might not sound like a huge number in, like, a giant refinery setting.
Well, no, but you have to remember, this is a portable ducted unit. And the sources are really clear on this. They call it the largest portable ducted blower for high-volume air movement available. That's a pretty big claim.
The largest portable. Okay, so does that massive motor come with trade-offs? I'm thinking, is it super heavy, hard to move around? Does it draw too much power for a temporary generator on a site?
That's a great question, and that's really where the smart design comes into play. It's not just about brute force. The motor is engineered to maximize its CFM, the cubic feet per minute output for its size.
Okay.
It's about efficiency. The way the motor is wound, the design of the fan blades themselves, it's all built to create this industrial-level velocity. The goal is to literally scour a tank of contaminants, not just, gently move the air around.
So we're not talking about simple circulation. This is an aggressive directional purge.
Exactly. Think about it. A welder has to go into a tank. The second they start welding, you get fumes, heat, oxygen displacement.
Right.
The velocity from this unit is designed to do a full air change cycle in just a few minutes, not the half-hour you might get from older, weaker units.
And that speed is what lets a safety inspector sign off on the work permit.
That's it. LELs drop, the risk profile drops, and work can begin instantly.
Which brings us back to the economics of it all, the stuff that procurement teams really care about. If you can clear a space with one of these instead of 3 or 4 older ones...
You're saving a huge amount of time. And money.
Yeah.
Absolutely. You cut your deployment time, you need fewer power drops, and less labor to set up all the ducting. It's a massive return on investment just by speeding up the mandatory safety part of the job.
Okay, that gives us a good technical baseline. So now let's talk about where this thing has to live. The source material calls them hellish industrial zones.
And that's not an exaggeration.
So segment 2, design, durability, and how this machine is built to take that constant abuse.
The conditions are just brutal.
Yeah.
This is not something you buy at a hardware store. It's made by Aramco Safety, and they're known for building tough gear. We're talking about surviving more than just a drop.
Right.
It has to survive corrosive chemical environments, big temperature swings, constant vibration.
The sources mention shock-resistant housings. What does that mean in practice? What kind of materials are we talking about?
Usually it's a high-density, specialized polycomposite. It's not just tough, it's also chemically inert. So it won't corrode when it's sucking out, say, hydrogen sulfide gas or other petrochemical residue.
So it won't break down.
Exactly. A standard metal housing would just get eaten away. And a lot of times the components are non-sparking, which is critical in an explosive atmosphere.
And I imagine that durability extends to the functional parts too, like the ducting, because if you have this incredible motor, but the duct connections are leaky...
You've defeated the whole purpose.
Yeah.
You'd be pumping toxic air right back where you don't want it.
Yeah.
The design has these really secure airtight attachments that can handle the pressure. A leak is a total failure of the safety system.
You know, something I found interesting was the supplier making a point about compatibility. They specifically mention how this big EG8200 works with smaller units like the RamFan EG8000. Why is standardizing gear like that so important for, say, a huge utility company?
Oh, standardization is a massive advantage for procurement. Think about a company with 50 different sites.
Hmm.
If every site uses the same family of equipment, same power cords, same duct sizes, same operating manuals, you just simplified everything. Maintenance, spare parts, and maybe most importantly, training.
So any crew at any site knows exactly how to use the equipment safely.
Reduces human error, boosts uptime, it's huge, and it gives them flexibility. You use the big EG8200 for a massive tank purge, but maybe the smaller EA8000 for a simple manhole job. But it's all part of the same system.
And the sources also mentioned different versions, like a CE variant or hazardous location blowers.
Yeah, that just shows the platform is adaptable. It can be configured to meet really specific international standards, like ATEX for explosive environments. It's not a one-size-fits-all solution.
Okay, so this is where we get to move from the specs on a page to, well, the stories from the field. How does this massive airflow actually deliver results in these high-risk industries?
Right, let's get into the applications.
Let's start with petrochemicals. The turnaround. Paint a picture for us.
Okay, so a turnaround is when a whole section of a refinery shuts down for maintenance. Every day it's down, it costs millions. And one of the biggest bottlenecks is just purging the vessels of hazardous gas so people can get inside.
And that's where the EG8200 comes in?
It just crushes those purge times.
Yeah.
I mean, an older system might take, say, 5 or 6 hours to get a big crude tank safe.
Okay.
The EG8200 could do it in maybe 90 minutes. And that's not just a small convenience.
Okay.
Cutting that time down can shorten the entire turnaround by a full work shift. That gets production back online so much faster.
Which makes the CFO very happy.
And the safety inspectors. Everybody wins.
Okay, what about another example? Tank and vessel maintenance, maybe in a shipyard or something.
Yeah, think about needing to make a space breathable. You can either use positive pressure pushing clean air in or negative pressure sucking the bad air out. When a crew is suited up and ready to go, they can't wait for hours. They need that atmosphere to change now. This blower's volume lets a supervisor establish that pressure change almost instantly. It cuts way down on paid overtime where crews are just waiting.
And the third one you mentioned, shipbuilding and utilities, tight spaces, tight deadlines.
Absolutely. In a shipyard, you have hundreds of little compartments that all need ventilation for welding or painting. The EG8200 can push clean air through really long runs of ducting without losing much pressure.
So you can ventilate more areas with fewer units.
Fewer units, less setup time. For utilities working in underground vaults, it's the same deal. It lets them hit deadlines they just can't afford to miss.
So what this all really means for you, the listener, is that a technical spec, that 1.5 HP motor, is directly connected to safety compliance and, well, keeping people alive. This machine is the ticket you need to even enter the workspace.
It's the first line of defense. No air change, no entry. It really is that simple. Which brings us to how you even get these things.
Exactly. Let's shift gears to the procurement side of things. This isn't a simple purchase. The B2B relationship seems really key here, and the source highlights suppliers like PEnergy.com.
It's a very specialized world. Their whole audience is oil and gas, heavy industry, utilities. Their business model is built on understanding the regulations and the pressures of those sectors.
They talk about wholesale pricing and zero boutique markups. How does a big company even verify that, and why is that so important to them?
Well, in the world of big capital spending, transparency is everything. A promise of zero boutique markups signals an efficient, lean operation. It lets the procurement officer show they're being fiscally responsible.
So they can prove they got the best possible value on essential safety equipment.
Yes, which improves the ROI calculation before the blower even gets turned on.
And it seems like the service has to be just as specialized. They mention having industrial-savvy sales experts. What does that actually mean? What makes them different?
A regular sales rep knows the part number. An industrial-savvy expert knows the application. They speak the language, they understand lead times, complex freight terms for heavy equipment, and how to help a client configure a huge order for an audit. They can give you real, field-tested advice, not just read from a catalog.
So they're more like consultants, solving logistical problems, not just processing orders.
Exactly. And the supply chain has to be just as robust. Think about an entire multi-billion-dollar refinery waiting on your delivery.
Yeah, no pressure.
Right. So the supplier has to have deep inventory, enough for a major shutdown or maybe a surprise audit where every plant in a region needs to upgrade their gear at the same time.
Inventory built for scale. I see that. For expansions or even emergencies where gear needs to be replaced immediately.
Precisely. And they need the logistics to handle multi-site rollouts. Shipping dozens of these to 5 different plants across 1,000 miles, all coordinated. That's what they mean by end-to-end service, from the first quote to aftermarket support.
This has been a really fascinating look at a single piece of tech. Let's just quickly pull together the main takeaways here.
I think the key thing is that the RamFan EG8200's design, the powerful motor inside that tough Aramco build, delivers just unparalleled speed and volume for clearing hazardous air.
And that directly improves safety while cutting down on expensive operational delays. So the final synthesis seems pretty clear. When you analyze this blower, you see how moving a massive amount of air translates directly into more airflow per dollar, per operator, and per hour.
Which is really the ultimate metric for ROI on critical safety spending in this world. It connects safety, efficiency, and profit.
Okay, so that brings us to our final provocative thought for you, the learner, to chew on. We've established that this technology is all about speed clearing toxic air and lowering LELs faster to boost profits and ensure compliance.
Right.
So here's the question. If the speed of ventilation has such a direct impact on the bottom line, what kind of long-term risks might pop up when procurement teams prioritize only that immediate cost saving and speed? What happens if, to afford the best blower, they delay maintenance on other, maybe less visible safety systems?
That's a great question. That tension between immediate gains and long-term holistic safety is always there when the stakes are this high.
Something to think about. We'll see you on the next Deep Dive.